chapter 4-2 is what we're learning is the unit circle. You don't have these notes with you, but that's okay. These are all things that you should have learned in geometry. So trigonometry is what we're starting, and it all deals with the unit circle. If you have the word sine, that is understood to be sin. It's not sin, you call it sine. Do we all understand that? Cosine is going to be cos, just cosine. Tangent, tan. Cosecant, secant, cotangent. The ones we're focusing on today are going to be these two right here. Okay? Biggest thing I need your brain to understand is that sine is going to be your x value. I should say cosine is your x value, sine is your y value. And if you put them in alphabetical order, you'll never forget that. So what I want you guys to think about is just simply putting them in next alphabetical order. Cosine, sine. And you guys will get these notes tomorrow whenever I actually go through it in class. Next, SOHCAHTOA. Biggest thing is y'all don't know how to spell it. No one ever remembers how to spell it appropriately. Those are letters. Those letters represent specific things. Things that they represent are going to be hypotenuse, opposite, and adjacent. Okay? Hypotenuse, opposite, and adjacent. The hypotenuse is the leg of the triangle that is opposite the 90-degree angle. It's the longest side. The opposite is the leg completely across the angle that you're talking about. And adjacent is the side that is touching it. So if I give you this angle right here, this is just going to be alpha. We're talking about that angle right here. The opposite of it is going to be right here. Adjacent is touching it, and the hypotenuse is across the 90-degree angle, which is the longest side. Do we all understand those, yes or no? It's something that you learned previously. Now, with that being said, that tells me that sine is equal to my opposite leg over my hypotenuse. Cosine is equal to my adjacent leg over my hypotenuse. And tangent is going to be the opposite leg over the adjacent leg. Do we all understand that, yes or no? Okay, that's all great stuff. Now, we are going to go ahead and start with our unit circle. And I'm going to go to a different slide, so give me 1 second. Okay, this is what you guys have in front of you. Now, with what you have in front of you, we're going to go with what we did previously. We're going to go around the circle and we're going to start by degrees. So when we first went by degrees, we went ahead and we did 0 degrees. And then what is at the top, the North Pole? 90 degrees. What is over here at the far west? 180 degrees. What's at the South Pole? 270 degrees. And what is at the far east with 0 degrees? 360 degrees. Yes? Do we all understand that? We all good? Okay. Then, in order to find the next one, we went ahead and took 90 degrees and divided it by what? 2. So what's 90 divided by 2? 45. So now we're going to go around the circle counting by 45. 45 plus 45 is 90. Plus 45 is 135. Plus 45 is 180. Plus 45 is 225. Plus 45 is 270. Plus 45 is 315. Plus 45 is going to be 360. Do we all understand that, yes or no? Now, how did we get our other angles in quadrant 1? We took 90 and divided by 3. So what is 90 divided by 3? 30. Now we're going to go around the circle and add by 30 degrees. So 30 plus 30 is? Plus 30 is? 90 plus 30 is? 120 plus 30 is? 150 plus 30 is? 180 plus 30 is? 210 plus 30 is? 240 plus 30 is 270 plus 30 is 300 plus 30 is 330 plus 30 is 360. Any questions on how we just got the degrees? Do we feel like we understand that? Excellent. Okay, next, we're going to start doing radians. I'm going to give a different color. Okay? With that being said, what's the very first one I want to know? 0 radians. Then what's another dead giveaway? 180. What is 180 in radians? Pi. 180 divided by 2 is 90, so pi divided by 2 is 90. So what we're going to do is go around and count by units of 1/2. 1/2 plus 1/2 is going to be 2 halves, which is pi. Plus 1/2 is going to be 3 halves, which is going to be 270. Plus 1/2 is going to be 4 halves, which is going to be 2 pi. Yes? How did we get the 45-degree angles? We took 90 and divided it by 2, right? So now pi over 2 divided by 2 is going to be pi over 4. So this is pi over 4. 1/4 plus 1/4 is 2/4. What does 2/4 reduce down to? 1/2. Add another fourth to that, that gives me 3/4, which is going to be pi over 35 degrees, which is 3 pi over 4. Plus pi over 4 gives me 4 pi over 4, which is going to be just pi. Plus pi over 4 is going to give me 5 pi over 4. Plus pi over 4 gives me 6 pi over 4. What's a 6 pi over 4 reduced down to? 3 over 2. So I'm at 6 pi over 4 right here. So then 7 pi over 4 is going to be 315 degrees. And then add another pi over 4 to that, that gives me 8 pi over 4, which is what? 2 pi, right? Do we all see that? Next, I need to go ahead and come up with my 30 degrees. How did I come up with my 30 degrees? Divided by 3. So what is pi over 2 divided by 3? It is pi over 6. So now I'm going to go around the circle and count by 1/6. Yes? 1/6 plus 1/6 is 2/6. What does 2/6 reduce down to? Pi over 3. So 2/6 plus 1/6 is 3/6. What does 3/6 reduce down to? 1/2. So 3/6 plus 1/6 is 4/6. What does 4 over 6 reduce down to? So this is 2 pi over 3. So that's 4 pi over 6, right? So 4 pi over 6 plus 1/6 gives me 5 pi over 6. Plus 1/6 gives me 6 pi over 6. What does 6 pi over 6 reduce down to? 1 pi. Yes? So 6 pi over 6 plus 1 over 6 is going to be 7 pi over 6. Plus a pi over 6 gives me 8 pi over 6. What is 8 pi over 6? 4 pi over 3. That's 8 pi over 6. Plus pi over 6 is 9 pi over 6. What is 9 pi over 6? What is 9 pi over 6? 3 halves. Very good. So I'm going to go ahead and take 9 pi over 6 and add another one. So that gives me 10 pi over 6. What does 10 pi over 6 reduce down to? 5 pi over 3. That's 10 pi over 6. 10 pi over 6 plus pi over 6 is going to be 11 pi over 6. 11 pi over 6 plus 1 pi over 6 gives me 12 pi over 6, which just happens to be the 2 pi. Does everybody understand how I came up with all of those radians? Do we get that, yes or no? Excellent. Okay, the next thing I'm going to have you pick up is another color, unless you want to keep doing it in pencil. We're going to do our radiant, not our radians, but our quadrants. Where's quadrant 1? Top right-hand corner, and that's going to be plus plus, meaning every x coordinate and every y coordinate, they are both positive. Where's quadrant 2? Where's quadrant 2? Top left. And that's going to be negative positive, so all the points in that quadrant have a negative x but a positive y. Where's quadrant 3? Bottom left. And those are both going to be negative. And where's quadrant 4? Below quadrant 1. And that's going to be positive negative. We're pretty good so far. Okay, now, that brings us to the last thing that we need to talk about. Oh, nope, we forgot one more thing. The other thing that I forgot is going to be the decimal equivalence. The decimal equivalence. What is the decimal equivalent of pi? 3.14. What's the decimal equivalent of pi over 2? Yep. 1.57. What is the decimal equivalent of 3 pi over 2? 4.71. And what is the decimal equivalent of 2 pi? Yep. Okay, does everybody understand the decimals and why we need them? Because that gives us our quadrants. We all good? Excellent. Now, the last thing I want to talk about is if we were to plot this on an XY axis, okay? The origin is smack dab in the middle, right? What is this point over here? If it's called the unit circle. 1 unit. So what would that word pair be over there? If I graph it on the XY axis. 1, 0. So 2 pi corresponds to the point 1, 0. What does 90 degrees correspond to? 0, 1 corresponds with 90 degrees because it's the unit circle. It has a radius of 1 going out in every direction, north, south, east, west. What does pi correspond to? -1, comma 0. What does 3 pi over 2 correspond to? 0, -1. What does 2 pi correspond to? 1, 0. All right, now what we've started to do is to write down the x and the y coordinates. Remember what I talked about previously. What does x correspond to? What did I say x corresponds to? I said that x corresponds to your lovely little cosine, yes? X corresponds to your cosine, and sine corresponds to your y. That's what we talked about, correct? Now, what I want to do is I want you to now take a 45, 45, 45 degree triangle, okay? 45, 45 degree triangle, and this is a theorem that you learned in Algebra 2, or I should say in geometry. That in a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg. Well, the leg of our unit circle is going to be our radius. So that's why our legs are 1. Do we all understand that? Our legs are the radius of our unit circle. It's 1. Do we all understand that? So how do I find the cosine of 45 degrees? The cosine of 45 degrees, as we know, is going to be adjacent over hypotenuse. The adjacent side of this 45 degrees right here is going to be the angle that the leg that is touching it. So that's going to be 1. And the hypotenuse is going to be the square root of 2. So how do I deal with 1 over the square root of 2? Do I like that mathematically? No, you have to rationalize that. So that's the square root of 2 over the square root of 2 to give you the square root of 2 over just 2. That is going to be the cosine of a 45 degree angle. Do we all understand that, yes or no? Now, how do I find the sine? The sine is going to be the opposite leg over the hypotenuse. Well, the opposite leg of 45 is right here at 1. Yes? And then I'm going to simply divide that by the hypotenuse, which is the square root of 2. And again, you're going to get the same exact thing right here. Yes? So what ordered pair corresponds to a 45 degree angle? The x coordinate, which is the cosine, is the square root of 2 over 2, and the y coordinate, which is the sine, is the square root of 2 over 2. So this ordered pair is what is going to be paired with every 45 degree angle. So if I come back over to my lovely unit circle, at 45 degrees, I'm going to add the ordered pair, square root of 2 over 2, square root of 2 over 2. That's the point that corresponds to it. Now, funny thing about it, the reason why my cosine is positive and my sine is positive for 45 degrees is because I'm in quadrant 2. But if I'm in quadrant 1. But if I'm in quadrant 2 and I want to look at the 45 degree angle in quadrant 2, that is talking about 3 pi over 4. Its point is exactly the same as 45, except for its x value is now going to be negative square roots of 2 over 2 and positive square roots of 2 over 2. Does that make sense? The 45 degree angle in quadrant 3 is going to be 5 pi over 4, and that ordered pair is going to be what? Negative square root of 2 over 2 and negative square roots of 2 over 2. Do we see that? And in quadrant 4, it's going to be 7 pi over 4, which corresponds to a positive x value, but a negative y value. Do we all understand why the 45 degrees is on exactly the same line all the way around the circle? Yes? Okay, well now we're going to go back and we're going to now do the theorem for the other triangle. The other special right triangle that we have is going to be the 30, 60, 90 triangle. Would you agree? When you have a 30, 60, 90 triangle, the hypotenuse is twice the length as the shorter sides, and the longer leg is square root 3 times as long as the shorter leg. The shorter leg is going to be attached to the 60 degrees. The longer leg is going to be x times the square root of 3, and then the longest leg, which is the hypotenuse, is going to be 2 times x. Do we all understand that, yes or no? Okay, now, remember x is your unit circle. That's the radius, so that's going to be 1. So I have 1, square root of 3, and 2. So if I'm talking 30 degrees, I want the cosine at 30 degrees. So that's going to be adjacent over hypotenuse. Well, my adjacent leg of 30 degrees is what? What's the adjacent leg to 30 degrees? It is the square root of 3. And what is the hypotenuse? 2. So my lovely little cosine of 30 is going to be the square root of 3 over 2. Do we all understand that, yes or no? Okay. What about the sine? The sine of 30 degrees is going to be your opposite leg over your adjacent hypotenuse leg. So what is the opposite of 30 degrees? 1. And what is the hypotenuse? 2. So what ordered pair will correspond with a 30-degree angle? That's going to give you the that's going to give you the square root of 3 over 2, comma 1/2. So we're going to go back to our level unit circle, and I'm going to find 30 degrees. What is 30 degrees? Pi over 6 angles, right? So my pi over 6 angle is right here in quadrant 1, and that's going to be the square root of 3 over 2, comma 1/2. Do we understand that, yes or no? What is my 30-degree angle in quadrant 2? Nope. It's going to be the 5 pi over 6. Look at your denominators. Now here's what I need your brain to see. All of the 45-degree angles have a denominator of 4. All of the 30-degree angles are hovering around the x-axis have a denominator of 6. All of the 60-degree angles are hovering around the y-axis, and they have a denominator of 3. Do we all understand what I just said? So I'm in quadrant 2. So this is going to be 5 pi over 6 is going to correspond with negative square root of 3 over 2, comma positive 1/2. Then in quadrant 3, I'm going to have 7 pi over 6. So what is 7 pi over 6 going to be? Negative square root of 3 over 2 and negative 1/2. And in quadrant 4, which is 11 pi over 6, that's going to be positive square root of 3 over 2 and negative 1/2. Do we all see that, yes or no? Okay, so we get our points for our 30 degrees. Now what do I need to do? I need to do my points for my 60 degrees. So if I need to do my points for my 60 degrees, I'm going to come back over here and I'm going to do my 60-degree one. And if I want the cosine of 60 degrees, that's going to be my adjacent over my hypotenuse. So 60 degrees is right here. So what is adjacent to 60? 1. And then what is the hypotenuse? 2. What is the sine of 60 degrees? That is going to be your opposite leg over your hypotenuse. What is opposite 60 degrees? Square root of 3, sorry, that's a 3. And then over the hypotenuse, which is 2. Now, that should make you be like, well, what's going on with that? Why are the cosine of 30 and the sine of 30, why are they the same? Why is the cosine of 30 and the sine of 60 the same? It's the same triangle. You can't change the numbers that are in the triangle, can you? And every single thing comes from that triangle to be able to get sine and cosines. Do we all get that? So once you have the lovely values for sine and cosine for 30, you automatically have the values for 60. We're simply going to swap them so we all understand that. So at 60 degrees, I'm going to have the ordered pair 1/2 square root of 3 over 2. In quadrant 2, what is that going to be? Negative 1/2 square root of 3 over 2. In quadrant 3, it's going to be negative 1/2 negative square root of 3 over 2. In quadrant 4, it's going to be positive 1/2 negative square root of 3 over 2. And that, my children, is the unit circle. Now, how in the heck do you memorize that?
Very good. I don't know.
There's some lovely little tricks to it. Are you listening? How do I remember my radians? My radians can be remembered by looking at the denominators and counting down. 2, 3, 4, 6. 2, 3, 4, 6. And if you look in both directions, and you go from the North Pole down, you can see that they mimic each other. 3, 4, 6. Do we see that? If you go to the South Pole and you go up toward your x-axis, it does exactly the same thing. 3, 4, 6. Do we all see that? Yes or no? So that makes it really super easy to remember your radians. Another easy way to remember your points, your x and y coordinates. Can you picture the hands of a clock? When you picture the hands of a clock, you see the hands of the clock. This is 12, 1, 2, 3. Would you agree? Well, what we're going to do is we're going to take the hands of the clock and we're going to refer to them as our numerator of our cosine. 1, 2, 3. Isn't that sweet? Hands of the clock, the cosine is 1, 2, 3. The cosine of 60 is 1/2. The cosine of 45 is the square root of 2 over 2. And the cosine of 30 is going to be the square root of 3 over 2. Do we all understand that? You have to remember every single thing on this paper. This is going to be an 81-point quiz given to you this Friday. You will have Math Excel on Thursday. When you are done taking your unit circle quiz, you will use the rest of the time in class to finish your Math Excel on Friday. And that will be your homework for the weekend. Any questions? Do not think you can walk in there on Friday and not have practiced this and be excellent at it. You will not have a calculator. You have to memorize everything and process through it. Any questions about what I just said? Okay, the rest of the time is yours to practice on the extra one that I gave you. We are actually not out of here for a while, so you guys have some time to practice. Yes? Okay.